So, hello everybody here at the IBC 2015, here at the Maxon booth. We have a great lineup of presenters and speakers here, and the next one is going to show something that was or had a premiere yesterday. It hasn't been shown to the public before, so this is the second time ever that he's going to show this. It's a guy that is the product manager of NVIDIA, and he's going to show the Iray integration via plug-in into Cinema 4D with 2 graphic cards. So please welcome Mr. Steffen Römer.
Thank you. Welcome everybody. My name is Steffen Römer. I'm working as a product manager for rendering software at NVIDIA in our German office in Berlin. I'm going to introduce you to a new technology you might have heard of, that is Iray, a physically based rendering engine that is fully GPU accelerated, now being integrated into Cinema 4D for the first time. I'm going to show you a little bit how it performs on that machine that I got here. It's a regular PC. It got 2 latest Maxwell generation M6000 GPUs in it. It's in total about 5,000 cores on these GPUs. I'm going to use them for rendering. I have to share that a little bit with the OpenGL preview, but you will see that performance is okay. Just to introduce Iray a little bit, I don't know if you have heard of that. NVIDIA has been developing that technology for several years now. It's coming to market in several products. Cinema 4D is one of the products where it has not been available yet, and we are trying to reach this market as well with our physically based rendering engine. So let me just start with the scene and explain a little more why we look at the scene. So it's a regular cinema. It's registered as a plugin like all the other render plugins. I've already created a little startup menu to help me manipulate that. So it adds some new icons here. Let me load up a scene that is... Oh, somebody used the machine for something else. So what I have here is basically a set from WizardT in the same hall here. I'm going to show you a little bit what such an interior environment, which poses a real problem to rendering, to physically based rendering, what kind of a performance you can expect with a GPU-based renderer. So this is a regular OpenGL viewport. You have in your render settings, you have the typical integration of Iray now. Looks very simple because a physically based renderer actually exposes only few options. The render itself is physically accurate, so it gives you predictable results without many knobs that you have to tune. Here's my render settings that I have. It's pretty much only the pass length, the light bounces that somehow controls the quality of your lighting. I've tuned it a little down to get some more better interactive performance, but that's about it. You can have some advanced options to introduce some caustic effects or so, but I turned that off for now. In the resources section, you can actually select which kind of GPUs you want to use. I have the 2 GPUs here. I will use both of them. You can even use the GPU if that makes sense. In our case, it doesn't, because it doesn't really contribute. You have some render settings on the left, where you can tune for certain quality settings. I'm using that now for my regular render. So you have your typical Cinema 4D workflow. Let's say I've started up the picture viewer, which is your typical tool to render your final imagery. You see it progressing here. Let me just enable the color profile. So you can use it as before. This is non-interactive, just final frame. You selected your number of iterations or number of the time it takes to finish your render. You see how fast it is on this machine. It's a 2 GPU machine only. So you get a present quick look of your render. But what's really interesting is this integration, because it uses the GPU, allows you to do something more interactively, to actually change your current workflows and work in your scene while you render at the same time. So we have the same thing basically here, rendering with this Iray on a GPU. And you are now able basically to manipulate your scene and see almost instantaneously how it reacts to your camera changes. You can let the mouse go. It resolves to define the quality, and that quality in this case here is just indoor lighting with few light sources. I just took the scene as is from the WizRT guys. It's not really set up for physically correct lighting. We come to that later, because all the light sources that they use in cinema by default is non-physical. This is like a point light or something like that. You need to translate that to something that's physically plausible, like a shape, right? So that is all possible. At the moment, it's a manual process. This kind of thing you see here is basically out-of-the-box rendering with an automatic translation of the effects to the internal physically correct light source types. So you have, let's place it here in a window. So that gives you an impression of the kind of performance you can expect with the latest graphics cards. This is now using 100% of both GPUs in compute mode. So here at the bottom, you see the typical Cinema 4D materials. And I also created some MDL materials. That's another technology that NVIDIA has been developed together with this rendering technology, because all the traditional materials typically also not physically accurate. There's a lot of shading tricks in there. We have invented a standard that we'd like to establish in the industry that allows you to define materials independent of your renderer. It is highly flexible. You can construct any complex materials yourself, like you used to do with a shading graph. This construction is just more physically accurate. You cannot actually break physical rules. If you do a layering, a coating on top of a base layer, it's always guaranteed to keep physical laws in place, like energy conservation. So let me just pick one of these elements here. I'm trying to tune that material here now, just to give you an impression of the interactivity. So that is now an automatic translation built into the plugin. You see it immediately affecting the lighting if you change the material properties themselves, like the reflection. It has an impact on the overall lighting situation, so that's why you have to basically re-render everything. And Iray is not doing any compromises. It doesn't use any caching techniques or anything. It's always accurately recomputing the full lighting solution and your scene. So I'd like to take that thing. Let me stop that scene for now. Use another one to show you some more of the material effects. This is all demo scenes from Cinema 4D themselves. Just a little bit optimized for Iray and rendered with Iray. live. So that is a total indoor scene. It has no light, no direct light at all. There's a lamp inside, but it's turned off. And I let actually sunlight shine in through the window from the outside. This is one of the most challenging situations for a renderer, and something you could not replicate with a graphics OpenGL renderer. So you get already an impression of the lighting situation. Now all the light is coming from the outside. It takes a long time to reach all the corners in the room. And so what this plugin is doing in the background, it's basically listening to all the changes I do in the scene and trying to apply that to the rendering. That is something unique to Iray in that case, because Cinema 4D itself, its interactive capabilities of rendering very limited. You're probably familiar a little bit with the interactive render region, which is also supported with this plugin, but that is much more interactive here. So you see it resolving quickly. It has already some more advanced materials applied to it. There's a wooden floor with some reflection properties that are more difficult. There's a carpet there. There's a stone wall in the end. I've selected actually a low preset for the moment. So it stops after a few iterations for now. We can go higher than that. I've actually set up a more accurate profile for the render settings to get more bounces in it. But when you are rendering that, you can still manipulate the scene and see it reacting in almost immediately. So it needs to re-export the scene for Iray. So one thing which is in that scene here is the physical sky from Cinema. So there's already physical-based solutions in Cinema themselves, and we translate that underneath into Iray representation of that. And you can take that sunlight and actually manipulate it interactively. Yeah? You see it basically immediately affecting your scene. Let the mouse, release the mouse and let it render. So the quality that you achieve pretty much depends on your GPU or hardware in the system. This is the quality on that system here. You have the ability to plug more GPUs in it. It will automatically take into account, because Iray is based on two other NVIDIA technologies underneath, which is CUDA, that's the programming interface, and optics. Optics is a Raytracing library that makes it easy for programmers to implement their own renderer. And that automatically guarantees that any GPU you add to the system will be taken into your renderer. So in that case here, this is the performance you can expect. I need to recompute that. So let me talk a little bit about the material system here in that scene. So you see already that the physically based lighting approaches are supported. Makes it very easy to use. Sun and sky system is very easy to use in contrast to what you used to do before to set it up. Of course, there's HDRI image-based lighting implemented as well. that allows you to capture your lighting environment in the real world and put it into your virtual set and render that with push of a button. Nothing easier than that these days. There's also possibilities to let geometry emit light, so you have emission properties in Iray. And there's, of course, a way to support traditional light sources that need to be translated somehow into physically plausible things. So here I'd like to, let's say, take my wood material, which is an MDL-based material. It's properly integrated here into the material editor of Cinema 4D. You have basically a reference to the external material definitions that you see here listed. I'd like to take another one, let's say the mahogany floor. So that allows you to take materials that you receive from external sources and put that into your scene. You have parameters exposed like you used to do in the past. It's the same thing. You can tune them. So you can tune your materials in Cinema 4D with the typical material editor. The other way would be you actually take an external editor where you can create your material constructions with external tools and then import that here into Cinema 4D or any other Iray rendering product. So let me choose another one. That was probably walnut. Just to get an impression. So that material is imported into Iray, and since it's a definition language, it's somehow compiled and then applied to the rendering. In this case, it's even more complicated. Material construction is a base wood material with a coating on top. And it's rendering a lot of times. So let me select these elements and apply some different material like a carpet. So you see it immediately applied to the rendering. I guess I go back to low in this case. So the integration of Iray also provides controls for a physical camera. So you have options to tune your lens properties, like depth of field effects. You have a tone mapper that implements film effects afterwards. We can look at that right now. And also a shutter implementation to achieve motion blur. Motion blur is something that you would do in a final render. I cannot do it here in the interactive preview. So you can go to your camera. You have tone mapping here. You can change the exposure. That is all in render. There's no post-process involved. So whatever you do here will be applied immediately, and you see it re-rendering on the GPU. So the other thing is you can also do your regular interactive render region that you used to do in the past. Just overlaying the Iray renderer to the OpenGL viewport. So while it renders, let me open the render preferences. In the resources section, you have the opportunity to actually connect to a remote GPU server. And NVIDIA has spent a lot of resources into allowing to use remote GPUs in the same way as you use as a local GPU. So there's no difference in the workflow you use. It's just using remote GPUs and actually a big cluster of remote GPUs for the same kind of interactive work. If you're interested to see that live, I recommend we go to the demo station afterwards because I have some trouble here on that station. But it's very simple. You basically log into a remote server that has, in our case, it's located in California. It has 16 VCA. VCA is itself is a server component that collects 8 GPUs in it. So you have a huge GPU power in the back, and your experience in the application is not different. Yeah? Of course, there's a little bit of latency, but since the rendering takes some time anyway, there's no difference in how you use the rendering. So we can probably look at that later. You have a little icon here what basically tells you if you are connected and how many of the GPUs you're using on a remote cluster. So that is something I'd like to show afterwards. So let me show that again here. If you would use the remote cluster in this way, you can actually achieve interactive frame rates with the same approach. The software itself doesn't need to be touched. You just add resources to it, and you see your live render updating much more quickly, actually resolving much more quickly than that one here. So you have, of course, speaking of the simplicity of using this kind of approach for interactive rendering, you have the opportunity to use the lighting controls that Cinema provides already to set a date and a time and see it reacting immediately. So no complicated setup of your directional light sources of the sky system. It's rather automatic. So that basically concludes my talk today. It's more a tech demo, so you see a lot of bits and pieces missing here. There's some update problem in that window. Maybe we use the picture viewer instead. You see that somebody triggers an update of the scene rendering, although I'm not touching it really. So the picture viewer is the other way of rendering your finals. You have the opportunity to render passes with Iray as well. Select them here, look at the passes, and use them in your compositing later on. So in that sense, Iray is fully integrated as a renderer, like you used to do with other renderers that Cinema provides. The material system is something that we're working on to actually allow you to edit the materials much more, the inner workings of the material actually. What you see is the interface of a material that has been designed by a material designer who gives the parameters to the outside what he wants to artists to tune. But actually, in the back, there's a full system that allows you to layer materials together that can be exposed in Cinema as well. So, but we are working with the Maxon guys how that could be done effectively, because the editing of materials inside Cinema is not very convenient at the moment, I would say. So, last but not least, let's talk a little bit about the traditional approaches and how that translates to a physically based renderer these days. All of the typical light sources you have in Cinema, they need to be somehow translated into something that has a shape, that has an emission profile, so that are new terms for people who used to do the old traditional lighting. There's something built into the plugin that tries to do that somehow magically for you. And then you have the choice to go in and tune that yourself. You can assign so-called emission profiles, which is kind of a directional texture that defines where the light should go, and other properties of physically based lighting. You can even take any piece of geometry and let it emit something in a certain direction. And that's the way to go. So that concludes my talk for today. If you have any questions, we have time to look at that. I also suggest to go to the demonstration afterwards if you have more questions about some of the details here. We can look at that. Thanks.